Hello folks, welcome back to our session 1. I am looking at a problem which is 1.2, and this problem could be out of your chapter, the book that you are using, 1.2, or it is there in the I have uploaded unit 1 problem set data on the blackboard. You can refer to that for this problem. So in this problem you are looking at a situation in which you can lease the equipment for $20,000, say $20,000. Then the unit production cost is $10, unit selling price is $20, and then the quantity to produce that they are looking at is 4,000. And so once you have that data information, the total variable cost is the product of the quantity that you sell times the unit production cost, which is 10. So that's the total production cost. The total cost is the sum of the fixed cost, which is the leasing cost in this case, $20,000, plus the total variable cost, which is $40,000. Okay. The total revenue then is the product of the quantity that you sold times what is the unit selling price. Profit is the difference between the total revenue and the total cost. Now in this problem there are about 3 sets of questions that they ask. What I would like to do is I would like to answer this using some of the functions that are built into the Excel, and what I would do is I will demonstrate to you how to use the goal seek function, how to use the data function, data table function, and how to graph the data that we have. Okay, this is the base case. So in the part A of the problem 1.2, what they ask is, so how large the leasing cost could be in place of $20,000 for 4,000 units that they are producing and selling before it becomes not profitable. Okay, so that is what we have to find. And in the second scenario, the question revolves around how large can the production cost be. Okay, so let me kind of blank that out, and always highlight the decision with the yellow. And so for the same fixed cost of 20,000, same selling price of $20, say $20 a unit, quantity of 4,000, not 400. Okay, so how large can the production cost be before it becomes not profitable at all to produce? In the part C of the question, it is with respect to the selling price and how small a selling price can be. For this data that we have, the operations becomes not profitable at all. Okay, what you could do is you can use the total profit equals total revenue, which is the selling price times quantity, minus the total cost, which is fixed cost and the variable cost of production. So if you take that, so when it says not profitable at all, set that equal to 0, and based on which part that you are addressing, A, B or C, you can have the algebraic formulation, and then once you go through the manipulation, you do basically get it as the fixed cost for part A. You can use this formula to get that. For part B, the variable cost would be given by this, and for part C, the price would be given by this function. Okay, now what I'm going to do is I'm going to get the relationship, and I'm going to use the data table to solve this problem. The total variable cost is equals the quantity that you produce times the selling price, now the production cost, that is a 1. Total cost then equals that plus the total variable cost, that 1, and the total revenue equals the quantity that you sell times the selling price, that's a 1, and the profit equals the total revenue minus the total cost. See, now I'm going to use the goal seek function. I'm using Excel 2007 version. You can go back to 97 to 2003 version, and accordingly you have to find for the goal seek function. So here I'm going to go click on data, and once I click on data, I will get this toolbar over here. I'll click on what if analysis, and here is the goal seek function. Okay, now I'm looking at how much can this be before this becomes not profitable at all. So my goal is to look at change this to get a value of 0 there. So the set cell is the target cell, and set that value to 0, and by manipulating this cell, okay, that is a leasing cost. When you click on OK, you get that. So before it becomes not profitable at all, the leasing cost has to be 40,000. If it is more than that, then this operation is not profitable at all. Okay, that's how you solve that one. And what I'm going to do is I'm going to copy the formulas. For this, I'm just going to go copy. I'm going to go and then paste them here. Paste them there, and also I will paste the same. Okay. See, now go back to your Excel tutorial, look at the copy and paste, copying the formulas, absolute reference, relative reference. So anytime that you copy and paste, just go back and click and see if he's pulling the information properly. Total variable cost there is nothing but the quantity times the production cost. Okay, so that has pulled that information correctly. And total revenue, yes, it has pulled the information correctly. So always double click and check to see it is picking the correct information from the correct places. Now in this case also you basically set the target cell, goal seek function, set the target cell to 0 by manipulating the unit production cost. And what that says is the unit production cost has to be 15 or less than 15 to make this operation a profitable one. So likewise for the selling price, the same thing. Go use the goal seek function. Set the target cell equal to 0. The changing cell is here the unit selling price. Click OK. So unit selling price, the least that you can have for the data that's given here, where the leasing cost is 20,000 and unit production cost is $10 in unit, at least the selling price should be 15 before it becomes profitable. Click OK. Now that demonstrates the goal seek function. So what I'm going to do is on the sheet 2, I have the information, and I'm going to show you how to use the data table and graph those things. Okay. Let me blank all this. Okay, let's say TC here represents the total cost, that's there. Total revenue is the total revenue. I'm going to graph against various quantities how the total cost and total revenue looks like. Okay, so the formulas that we had on the previous sheet, they're all here as you can see. Okay, and what I'm going to do is for various values of the quantity, okay, let's say in the increments of 200, so block that, go to the southeast corner, and now when you go that, it increases in the increments of 200 each. Okay, for these various values of quantities, what is going to be the total cost and the total revenue? One way is to keep on changing this value here for various quantity, record what the total cost and total revenue would be, here, keep on typing. So you would have gone through this at least about 20 times before you can populate the table here. Of course, there is an easy way out. Now in this model, where do we write the total cost? So go here, put equal to sign, the total cost is written there, give that reference, and likewise over here, go to total revenue, and total revenue is given there. Okay, click that one. Now you go, you block all this, then go here under what if analysis, go click on the data table. Now here it says the row input cell. So once you click on the data table, this is the dialog box that you get. Now look at that. Our quantity, various quantities, is arranged in a column, not in a row. So that's why row input cell is going to be empty in the column input cell. So here, this is where I have the quantity arranged in a column fashion. And where does this quantity goes? The quantity goes right there. So what the Excel does is it takes each value one at a time, inserts it over there, and then records what the corresponding total cost, total revenue, and records that information against that quantity like that. So once you hit click, it populates immediately. Okay. Now what I want to do is I want to graph this against various quantity, what is the total cost and total revenue. Okay. Now to do that, what I'm going to do is I'm going to go and then highlight this. Then click and hold the control button. Click and hold the control button, go back and pick the other two columns. Okay. Now you'll see that it's slightly shaded and there is a very thin white column that kind of separates quantity against the two corresponding the output variables right here. Okay. Go click on insert. Now here you get different kind of graphs and all. The one that is suitable for us is for various quantities, what are the corresponding total cost and total revenue. It's like an X and Y relationship, so it's going to be a scatter plot. Okay, insert as an XY chart. So this is an XY chart. Click on that one, you get this various. So here you just get the data points. Here you get the data points connected with a smooth curve. Here you have a smooth curve without data points. Here you have data points connected by straight lines. Here we have the data connected without data points but with straight lines. So click on that one. Once you click on that, you get the graph here. Move it around and you can expand it. You can expand or collapse the graphs to make it more. So when the quantity is 0, the revenue is 0. Revenue is a function. So that's all we have is total cost at the time as a fixed cost, and this is the break-even quantity. Break-even quantity. You can go back. You can change the legends. Click series, edit one. So series name, series 1 is blue, which is the total cost. Then click on series 2, click edit. That name is total revenue. Once you do that, then you have that one. Click OK. So this is how you can have the graph. I ask you to go back and look at any reference book on Excel as to how to chart and do all those things. As I said before, the focus here is not on teaching you the Excel, but teaching you the management science concepts, okay, using Excel. Okay folks, what I would like to do over here is take the same data that we had in the earlier problem. Okay, now here find the break-even quantity with respect to the data that we have here. I will use the goal seek function. Now here again is the data table in which I will change two things at a time. That is price for various price of $15, $20, $25, $30, variable cost 5, 10, 15 and 20, and for this what is the corresponding break-even quantity. Okay, break-even quantity is in our table here is given by that. Okay, so I'm going to put it there. Now I'm going to use the goal seek function over here. Click on data, click there, goal seek function. Okay, set the target cell, the profit to 0, and what is that quantity that fetches us this? Okay, so that is now for us to break even for this given data set, we should produce at least 2000 quantity. Now for various combinations of the selling price and the variable cost of production, what is the corresponding break-even quantity? That's what we want to do it here. Okay, now so that basically is, if you want to go and do it by hand, it's a 4x4, that is 16 combinations is what you have to keep on doing it here to populate that. Let's just use the data table here. So now here, this is where I refer into the model where the break-even quantity is calculated. So that is a reference. Now go and then block the data. Okay, click on the what if, go for the data table. Now here we have two things that change. One is the price that's arranged in a row, the other one is variable cost that is arranged in a column. Yes, row input cell, it is price, and where is the price here? The price is over there, give that reference. Now here is the column input that represents the variable cost, and this is where it goes into the model, give that reference, click OK. Now it tells you, well, there is something wrong here, let me try to fix it. Folks, there seems to be a little problem over here. In 2003, 97 to 2003, this is how it was done. So looks like in 2007 I may have to do this in a little different way. I'll get back to this in my next lecture.